Hello, Hashima. This video is for Monday, June 1st. Today in math, we're going to be doing lesson 135, plot data on line graphs. So today we're going to be able to plot data on line graphs and analyze the trends that we see. So taking what we've learned about coordinates and graphing and then applying it to real life situations. You've probably seen line graphs before, but down along the bottom, there's 3 examples of what they could be. They could be about temperature, they could be about sales of cookies, they could be about rainfall, during a month. So you'll notice that on both axes, on both the X and the Y, there are labels telling you what it's measuring. So a line graph can show data on a coordinate grid. So basically the X-axis is for one variable and the Y-axis is for another. So on this one, it says days and degrees. This one is days and the number of boxes of cookies. This one is days and rainfall. So depending on what the data is that you're showing, the X and Y axis needs to be labeled, and then you plot the different data points on the graph. So I'm going to show you a model that I already did for you. So the example says 3 feet are equal to 1 yard, and you're going to use this information to complete the tasks. So you have a chart here of 3 feet, 1 yard. So it means that we're going to plot the coordinates. So over 3, up 1, over 6, up 2, over 9, up 3, over 12, up 4. And then it says to plot another point on that line. So I just did the next one, which would be 15 feet is 5 yards. So and this line would continue on and on and on and on and on if I extended the line and extended my graph. So the coordinates of that are 15, 3. I connected the points using a line. And then a rule for the line would be divide by 3, so y is equal to x divided by 3. So whatever x is, if you divide it by 3, you'll get y. So 12 divided by 3 is 4, 9 divided by 3 is 3, 6 divided by 3 is 2, 3 divided by 3 is 1, and there you go. So that's this one. Notice the x and y axis are labeled. So as the number of feet increases, so does the number of yards. Example B says, read and interpret the line graph. The first part says, describe how Fido's weight changed based on his age. So before I even get into the answer, just look at the graph for a moment and we're going to think about what it's showing. So the title is Fido's weight. And then along the x-axis, you have his age in months. So notice that the numbers down here are getting bigger. And then on this side, we have his weight in pounds. So this is time and weight. So if you notice, this line is going up, up, up as he gets older. And then he reaches a certain age and it kind of evens out. So it says, how does his weight change based on his age? So I wrote, as Fido got older, his weight increased quickly and then slowed down until it finally started to stay at the same around 20 months. So that's similar to a person, right? You grow really fast when you're little and then you start to even out as you get older. The next part says, during which months was Fido's weight change the fastest and the slowest? So when a change is fast, it's going to increase at a much steeper rate than when a change is really slow. So if you notice, and I'll mark this up so you can actually see, there's some really fast increases here and some slower increases, where to get from one, as you increase on the y-axis, it starts going slower. So this is not a line that extends the same no matter what, kind of like in example A. It's not like that. It's quite different. So you have to remember that you're, depending on what data you're showing, sorry, I'm just erasing this. You have to think about what it means and what it shows. So in this case, this is not a linear line. This is a line that's changing over time at different rates. So it's changing really fast at the beginning. It's jumping majorly. And then it starts to jump a little bit slower until finally it's staying the same. So I wrote, Fido's weight change was the fastest from 0 to 8 months. So from here to here. And then it slowed down from 8 to 20 months. And then once he reached 20 months, his weight stayed the same. So we could guess that if this line extended on, it would probably stay the same. It's never going to drop down super low anymore because he's going to be a full-grown dog. All right, so you guys are going to do, are you ready? And work it out. There's a few different questions for you to answer. Just think about what the data is showing you. And if you need to refer back to examples A and B, that will be helpful for you. And thinking about what these line graphs are showing, and we'll see you on Zoom later today. By the way, there is no exit ticket today. All the work that you're doing is in this slideshow. Have a great